All right, 9.2 is all about graphing rational functions. Now, rational function is anything that's in the form of y equals, or another name for y is f of x equals p of x divided by q of x. Now, that looks complicated, right? But here's the thing. Back at the beginning of the year, we talked about what a rational number was. A rational number that was anything that could be expressed as a fraction. And so that's all this is. A rational function is just anything that's a fraction. Let's consider this first rational function. Y is equal to 1 divided by x. P of x is 1. Q of x is x. It's just a fraction. That's it. All right? So here's the thing. What are the possible values of x? What numbers am I allowed to put in for x? Well, this is America. I can put in anything I want. I could put in 1. I could put in a half even. You could put a fraction in. It don't matter none. I could put in -8. I could put in negative pi. This is America. I can put in anything I want within certain limits. There's one thing I can't put in. The one thing we can't put in for x, we can put in everything except 0. Remember, you can't have 0 in the denominator. And anything divided by 0 is undefined. So if you have 1 divided by 0, when 0 is under, it's undefined. All right, now, what happens is x gets bigger and bigger and bigger. So let's think about this. If x is greater than 1, so let's go to 2. That'd be a half, right? And when x gets bigger, 1/3, 1/4. As x gets bigger and bigger and bigger, what's happening to the fraction? 1/10, 1/100th, 1/1000th. What's happening as x gets bigger and bigger? Well, the values of y approaches 0. It gets smaller and smaller and smaller, right? Instead of, let's just say it gets smaller. Oh my goodness. But will it ever go negative? No, even if I put in a billion, 1 divided by a billion is just really teeny tiny. So it gets smaller, but it's going to approach, y is going to approach 0, but never get negative. It's just going to get smaller and smaller and smaller. Now, what happens to y if the positive values of x are greater than, or excuse me, less than 1? So let's think about that. Like I said, this is still America, so we could put in a half. Well, 1 divided by a half is 2. What's 1 divided by a third? 3. What's 1 divided by 1/10? That'd be a 10. 1 divided by 1/1,000,000,000th would be a billion, right? So what's happening? It's getting bigger. Or if you think about it like this, y would be approaching, it's getting bigger and bigger and bigger with no limit. It approaches infinity. All right, so let's think about this. If you were to make a sketch, make a sketch of what you think this graph would look like without graphing it, right? So for example, coordinate plane, maybe you think it looks like this or something. Or maybe you think it looks like a smiley face. Let me tell you this, both of those are wrong. But take a guess. All right, let's go ahead and get out your calculator. Let's see what it really does look like. We're going to graph y is equal to 1 divided by x and press graph. How about that? Looks like that, right? Got these two little arms here and stuff like that. So here's the thing. This shape is called, now we graphed a shape like this back when we did conics. What do you think it was called? This is a hyperbola. The shape of this graph is called the hyperbola. Now, the two symmetrical parts, these two little curves here, these are called branches. Branches. And this graph actually has two asymptotes as well. An asymptote, we're familiar with those back from conics, is a line that the graph approaches, a line that the graph approaches but never crosses. A line that the graph approaches but never crosses. Now here's the thing. I gave you a grid here, right? So remember how I feel about grids. If I give you a grid, I want pretty points. So a couple of ways to do this. First thing, the way I'm a trace guy myself. Press trace and then plug in, I don't know, put in 1. You put in 1, you get 1, 1. So then plot that point. 1, 1 would be right there. Then put in 2. 0.5. What's going on here? Hey, just for fun, let's put in 0.5. 0.5, you get 2. So there it is there. So we got 3 points on this graph, and you can kind of see how this curves. Now look at here. We said as x gets bigger and bigger, y is going to get smaller and smaller and smaller, but it's going to approach 0. So that's what's happening here. It's going to get closer and closer to the x-axis where y is 0, but never quite get there. And as it turns out, it's doing the same thing when it goes up. It's going up forever and ever and ever, but never crossing the y-axis. Now, that's the trace way, but we got to find 3 points on this branch as well. So here's what's up. We're going to go to the table. Press second graph, and there's the table. Now, if you go down to -1, there's 1, -1, 1. So we can plot that point. -1, 1, or excuse me, -1, -1. -2.5, and then -3 and -1/3. So you can kind of see what's going on in here too. This is doing the exact same shape, only in quadrant 3. Now look at this. At 0, it says there's an error. Why is there an error when x is 0? Well, it goes back to here. 1 divided by, you can't put 0 in the denominator. So what that means is that x is not allowed to be 0. There is a vertical asymptote here. X cannot be 0. That's why this graph approaches the y-axis but never crosses it, because x is not allowed to be 0. And then there's also an asymptote at right here, because when x gets bigger and bigger and bigger and bigger, the fraction gets smaller and smaller and smaller, but it will never get to 0 or cross it into negative. It will just get smaller and smaller fraction. So there's actually 2 asymptotes here, and this is what the graph looks like. Now, for all these graphs, I'm going to want you to plot 3 points on each branch. And you can do it by using the trace feature, or like we did here, by using the table, whichever way that you like. All right, let's go on to the next thing. Now, here's the thing. The asymptotes of this graph are, oh yeah, we forgot to talk about that. X is equal to 0. Why? Because you can't have 0, or excuse me, 0 cannot be in the denominator. Zero cannot be in the denominator. Then that's this asymptote. Then this horizontal one, this is y is equal to 0. Why is that one? Because 1 divided by x, as x gets bigger, as x approaches infinity, y approaches 0, but will never be negative. Right? Now, even here, when it's negative, it approaches 0, but will never cross into the positive zone. Right? As x approaches infinity, y approaches 0, but will never cross it. Okay, so that brings us to this formula right here. for all rational functions in the form y is equal to a divided by x minus h plus k. This is going to have asymptotes as x equals h, because that's what makes the denominator 0. If x is h here, h minus h is 0, so that's why it can't be h. All right, and then there's going to be a horizontal. This is going to be your vertical asymptote. And then our other one is going to be at y equals k. And that's going to be our horizontal asymptote. All right, let's do an example of this. So right here, this is in the same form as it is up here. So the vertical asymptote is what makes the denominator 0. So in this case, what value would make the denominator 0? 6. So our asymptote is x equals 6. Or think of it as x is equal to h. H is the opposite of what you think. It's negative 6, so it's 6. Now the vertical asymptote, horizontal asymptote is plus k. So in this case, it's y equals plus k here is minus 3, so negative 3. All right, so we got our two asymptotes. This is the horizontal, or this is the k gives us our asymptote. X is equal to 6. That's going to be a vertical line like this. And y is equal to negative 3. That looks like that. All right, now let's pull out our calculator and see what this looks like. So the trick here is you got to put in 4 divided by. Now you want this whole thing to be inside, the whole denominator to be inside parentheses. So this is 4 divided by x minus 6, close parentheses, then minus 3. Make sure your denominator is in parentheses. Then press graph. Now look at our graph. Does this look like it might fit in what our asymptotes kind of sketched out for us? Sure. Looks like it's going to be down here in quadrant 4 doing its thing. So, like I said, I'm a trace guy. If you're a table person, go and get some values. So I'm going to start with like 7, 8, 9 maybe. So 7. 7, 1. 8, negative 1. Whoa. 9, negative 1, 2/3. So it looks something like this. Now remember, this is always going to go and skate along the asymptote, but never cross it. Never touch it or go past it. All right. Now the other one I'm going to go with 5, 4, and 3. This one's kind of far away from the other one, right? It's got a lot more curve to it. What do you suppose that is? So here's our other graph. Looking something like that. Okay, now the domain. What is the domain of this graph? If you remember, domain means all the possible x values. So here, what x values are being used by this graph? When we start here at negative 10, this blue line crosses negative 10, right? In fact, everything going to negative x, everything has got a point on this graph, right? Zero's got a point on this graph. Everything's got a point on this graph except what's the one thing that this graph does not use as far as x values go? Well, there's an asymptote at 6. X cannot be 6 because it makes the denominator 0, right? Same thing here. Here, everything's got a value on the graph. Every x value is on the graph. The only thing that's not getting used is 6. So here's the thing. There's a fancy notation for that. this bracket means the set of all numbers x, such that, and I know this is all weird, but here's the important part. What I need to see is x is all real numbers. That's that reinforced r, except what's the one thing that x cannot be? X cannot be 6. X is all real numbers except 6. All right, so that's our domain. Our range is the y values. So looking at y, we're looking at y here. Negative's got numbers on this here graph. Everything up except then there's an asymptote at -3, right? Does the blue line ever touch at -3? No. At -2, I got a point right there, right? And everything else has got a point on this graph. The one thing that doesn't is -3. So our domain is America. Y gets to be anything it wants. But there are some limitations, like you can't yell fire in a crowded theater. In this particular case, x cannot be -3. All right. Now, there's another form that is also a rational equation. It's in the form of fraction, but it's a little bit different. Now, the vertical asymptote remains the same. What makes the denominator 0? So, we'll look at that in just a minute. What makes the denominator 0? But the horizontal asymptote is going to occur a little bit differently. It's going to be y is equal to the ratio of leading coefficients of x. Look at this. Here's a and here's c. Those were the coefficients of x. Y is equal to the ratio of coefficients. Let's do an example here. The vertical asymptote here, we get the vertical asymptote. What makes the denominator 0? Well, let's see. 3x plus 3 is equal to 0. What makes it 0? 3x is equal to -3. X is equal to -1. If x is -1, that makes this denominator 0. So that means the denominator cannot be that, or x cannot be that. So let's draw our vertical asymptote at x is equal to -1. Horizontal. Horizontal is the ratio of leading coefficients. So in this case, it's going to be y equals a divided by c. What number's in front of x here? 1. So this is 1/3. This is going to be y is equal to 1/3. So it's in between the lines, but there it is. All right, so we use our calculator to graph this. Now, once again, be careful with your parentheses. We're going to have to put this whole numerator on top, and in order to make sure the whole thing is on top, use parentheses. Parentheses, x minus 2 divided by, make sure you close parentheses, and then divided by, then we got a new set of parentheses for the whole denominator. 3x plus 3. And there's our graph. Oh, what did I do wrong? My bad. Somebody should have said something. Where were you on that? Anyways, my vertical x is equal to -1, but I graphed it at 1. And I could see that, look at this, my graph definitely was not going to fit my skeleton with my asymptotes. I made a mistake, and none of you told me. Shame on y'all. Anyways, should be like that. Now it looks like my graph's going to fit, right? All right, that's better. So go ahead and plot your points, check your domain and range, and we'll see if we agree in the morning. Or in the afternoon, depending on what time I got you tomorrow. Smith out!